Another type of problem that you'll encounter when dealing with freezing point depression and boiling point elevation is figuring out how much of a solute is dissolved in a solvent. So we have our equations. This one's freezing point, but boiling point works about the same way. I times Kf times molality, and molality equals moles of solute over kilograms solvent. All right, so we're looking for the amount of a solute. The only thing I have in these two equations that says solute is this right here. So this is what I'm going to solve for. And then I can go from moles to grams just using molar mass, and that'll be easy. In order to solve for this, I need kilograms and molality. Well, I have my kilograms of my solvent, which is water, but I don't have the molality. That's where this equation comes in. I'm just going to rearrange it. Delta TF over I times KF. All right, then our change in freezing point. Well, they tell me my freezing point is lowered to negative 10 degrees C. Since we're dealing with water, water's normal freezing point is 0, so the amount it changed was 10 degrees C. I, in this case, NaCl, is an electrolyte. Now, you will not get a little hint like this when taking the AP exam. You need to look at that substance. If it is ionic, it is an electrolyte and it will split up. So this is going to split up into sodium ions and chloride ions. So in this case, since it splits up into two pieces, I is 2. And my Kf for water, my solvent, is 1.86 degrees C per molal. All right, working with that, degrees C cancels out, you get 2.67 molality. Now I can use this equation right here and take molality, or moles of my solute is equal to molality times my kilograms solvent. I just calculated my molality, so that's 2.67 molal times my kilograms, which is 4 kilograms of solvent. That gives me 10.8 moles of my solute NaCl, and then we'll just convert it to grams using molar mass. In 1 mole, there are 58.44 grams, and so you end up with a lot of salt. 631 grams of NaCl have to be added to 4 kilograms of water in order to reduce the freezing point that much. Another type that we'll work with is calculating molar mass. We'll actually do a lab dealing with this one a little bit later on. Now, one of the keys in dealing with these types of problems is using your units or knowledge of units. Molar mass has units of grams per mole. We want the molar mass of the solute. So I need the grams of the solute and the moles of the solute. In these types of problems, they will give you the amount of the solute, or like in the lab, you measure out that particular amount. So we already have that number, so all we need are the moles of solute. Here we're dealing with boiling point, so delta TB equals I times KB times molality, and molality equals moles solute over kilograms solvent. We want our moles of solute because that's what we need to get our molar mass. In order to do that, I need both kilograms of solvent and molality. I don't have my kilograms, but I can easily get it. I have grams. I'm going to move it over 3 places, so 0.038 kilograms. I don't have the molality, so I'm again going to use this equation, just rearrange it, delta TB over I times KB to get my molality. Delta TB, it changed 1 degree. 1, this is a non-electrolyte, or I is a non-electrolyte, so I is 1. And our KB for our solvent, which is water, is 0.51 degrees C per molal. So we'll solve for our molality here. I got 1.96 molal. Then I'll use this equation to solve for my moles. Moles of solute is equal to molality times kilograms solvent. My molality is 1.96 molal. kilograms, and to make sure it is kilograms, 0.038 kilograms. So that's going to give me moles of 0.0745. So to find molar mass, it's grams divided by moles. So I have 3.11 grams of my solute, and I just figured out how many moles of my solute are there. And I get a molar mass of 41.7 grams per mole. And that is the molar mass of our solute.